Hello friends, in this video we're going to discuss about the conditions for f of x and y to be maximum or minimum. So before we start, please subscribe the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you and help me to grow my channel. And if you want to follow me on Insta, this is my Insta ID, Ojha, O-J-H-A, L-A-K-H-Y-A-J-I-T 123. So this is the Insta ID. You can follow me on Insta. Okay, so now let's start. So in order to examine the maximum and minimum of a given function, so in order to determine the point where it's gonna have maximum or minimum value, and what are the conditions to have maximum or minimum at a particular point, we're gonna discuss here. So first, before we check it has minimum or maximum, first we have to determine the point of extremum. Point of extremum means the point where it gonna have maximum value or minimum value, right? That is called point of extremum. Okay, so now how to determine that point of extremum? Okay, so we need to determine first partial derivative of f with respect to x and partial derivative of f with respect to y, and equating these two with equal to 0, equating these two with 0, then we're gonna get two equations. Then solving these two equations, we're gonna get the solution for x and y, and this point will be called, from here whatever value we're gonna have for x and y, that point gonna be the point of extremum. Okay, it may be point of minimum or it may be point of maximum. Now one more condition, sometimes we may get multiple points, okay, depending on the type of equations from here we're gonna get. Okay, now you see, if we get a point, okay, any point, at that point, that point is a point of maximum or minimum, we have to check that one. Okay, how to check that? So once we get the value of x and y, we're gonna put the those values here. Here you see. So if you find once you found the first order derivative of this, then find the second order derivative of f with respect to x and second order derivative of f with respect to y. And if you put this value, put the point that put the values of x and y from the point that obtained solving these two equations. For that point, if the values of these two, product of the values of these two becomes greater than the square of this value. Okay, so you have to determine all these three. That means you have to find the second order derivative of f with respect to x, second order derivative of f with respect to y, then second order derivative of f with respect to x and y. Okay, then you have to put the value of x and y from the point that you obtain solving these two equations. Okay, if this condition is satisfied, then the point that you have obtained solving these equations, that is the point of extremum. Okay, now this point of extremum is the point of maximum or minimum. How to determine that? So again, putting the values of x and y, here in this one or this one, if we get that value is less than 0, then it is point of maximum. If we get greater than 0, then it is point of minimum. So let me give you an example, okay, so that you can better understand. Right, now let's solve these questions. So here you see, just wait. Okay, so first let me write the given function here. So we need to examine the maximum and minimum values of this function. So let me copy this given function. So let me write here, this is the given function. First let us find del f by del x. So differentiate it partially with respect to x, then here we're gonna get 3x squared, then this is gonna be 0 and minus 3y. That's what we're gonna have if you differentiate this. So now let's find del f by del y. Then what we're gonna have, now differentiate this with respect to y partially, then 3y squared, then minus 3x. That's what we're gonna have, right? Now let's find the second order derivative also with respect to x. If you differentiate this, that's gonna be 6x, and here we're gonna get 0. That means only 6x. And second order derivative of f with respect to y, right? That's gonna be 6y, right? That's what we're gonna have. So now you see what we are going to do is, first we're gonna solve del f by del x is equal to 0. Okay, and from here we cannot say product of these two is equal to greater than or is lesser than this second order derivative of f with respect to x and y. So first let me find this one, okay, before finding the point of maximum and minimum. So let me check this one. So differentiate this with respect to y again. So then you're gonna have minus 3, right? You're gonna have minus 3. So product of these two is greater than plus 3 or greater than minus 3 or less than minus 3. We can't say now because here we have still variables. So now let's solve this is equal to 0. If you solve this, then what you're gonna have, 3x square minus 3y is equal to 0, and dividing both sides by 3, then you're gonna have x square minus y is equal to 0. This is equation number 1. And similarly, let's solve del f by del y. That's gonna be equal to 3y square minus 3x is equal to 0. Sorry. So dividing both sides, here we're gonna have 6y minus x 6 sorry not 6 sorry y square minus x is equal to 0. That's what we're gonna have, right? So now you see, from this equation number 1, from this equation number 1, we can write y is equal to x square. Now let's put this value of y here. Then what we're gonna have, if you replace the y by x square, then you're gonna have x to the power 4 minus x is equal to 0. Here we're gonna write using 1. Okay, so if you solve this, then what you're gonna have here, x cube minus 1 is equal to 0. So which implies that either x is equal to 0 or x cube minus 1 is equal to 0, right? X cube minus 1 is equal to 0. Now you see, just wait, let me copy this last step. Okay, let me write here. So x cube minus 0 means what? If you apply this here, a cube minus b cube formula, then you're gonna get a minus b, that is x minus 1, into a square, that is x square, plus ab, that means x into 1, that is x, then b square, that is 1 square, that is 1, is equal to 0. That's it. We're gonna get that, right? Now if you solve this, then what you're gonna have, therefore x is equal to x minus 1 equal to 0, or x square plus x plus 1 is equal to 0. Now again here you see this is a quadratic equation. Now if you compare this one with this, ax square plus bx plus c is equal to 0, then comparing these two, you're gonna have here b square minus b square minus 4ac, that's gonna be equal to here 1 square minus 4 into 1 into 1, which is gonna be minus 3, which is less than 0. That means this equation has no real solution. That's why we're gonna ignore this part. So we're gonna take the solution of this part, that is x is equal to 1. So that's why we have got x is equal to 0 or x is equal to 1. So that means x, we are getting values of x 0 and 1, right? Now if x is equal to 0, then equation number 1, we're gonna get y is equal to, from this equation, y gonna be equal to 0 square, that is 0. And if x is equal to 1, then from equation number 1, what we're gonna get, y is equal to 1 square, that is equal to 1. So that means, so point of maximum, okay, point of maximum or minimum, that means we can say point of extremum, point of maximum or extremum, point of extremum is either 0, 0, when x is equal to 0, we are getting y is equal to 0, 0, 0, or 1, 1. So first we're gonna check which one is point of extremum, okay, before we write. If we use this value of x and y here in this equations, then you can see 4, 0, 0, right? 4, 0, 0. What we can have? We can have second order derivative of this with respect to x is equal to 0, and second order derivative of f with respect to y is also equal to 0, and their product, so their product will be also 0. Their product will be also 0. If you find the product of these two, which is also 0, and which is greater than minus 3, that means which is greater than minus 3 means here you can see this is minus 3. So that's why we can say this is greater than second order derivative of f with respect to x and y, right? So sorry, I made a mistake here. Actually we have to check this is greater than this one or not, square of this one, okay? So let me check this, just wait, give me a second. Okay, first let's find the square of this. Okay, so square of this, if you square it, then you're gonna get 9, right? So which is less than 9. So here you see this is 0 is less than 9. So that's why 0, 0 is not a point of extremum, right? Is not a point of extremum. So now let us find this product for this point 1, 1. Okay, so if you put here 1 and here 1, then what you're gonna have, then this product gonna be equal to, so here you see 4, 1, 1, 4, 1, 1. So value of this is gonna be 6, this is gonna be also 6 into 6, which is 36, that is greater than 9, right? So which is greater than square of second order derivative of f with respect to x and y, right? So that's why 1, 1 is the point of extremum, but yet we don't know minimum or maximum, so we're going to determine that. So let me go to the next slide. Okay, first let me copy these two. Okay, first let me copy this too. So let me put here square. Okay, this is a square, right? Here you see, as we have got for this point we are getting these two product is greater than this one, so that's why therefore 1 comma 1 is the point of extremum, but it is minimum or maximum we don't know. So that's why first let us find the value of these two. Second order derivative of f with respect to x, that's gonna be equal to 6 into 1, that is 6. Okay, so which is greater than 0. So this is the condition of minimum. This is the condition of minimum. If you check the first slide, here you see this is the condition of, sorry, this one. If it is greater than 0, this is the condition of minimum, right? So here you see, therefore point 1 comma this point 1 comma 1 is the point of minimum. Okay, point of minimum. This is the point of minimum. So now you see, therefore the minimum value of the function f of x comma y is f of 1 comma 1 is equal to, so what was the function? This is the function. Let me copy this, and here you see, so this is the function, right? So if you put here 1 comma 1, then what you can have, 1 cube plus 1 cube minus 3 into 1 into 1, so that's going to be 2 minus 3, that's going to be minus 1. That's what we're going to have. So hope you have understood this. Thank you for watching. See you in the next video.